Okay, so in this video, we're gonna go over setting up the Markdown file inside the R Studio. So the Markdown files are a really a new way of building a comprehensive environment in which you can generate PDF or Word or HTML pages of your code. At the same time, you can run this code inside R, which is really neat, and I think is the best way to learn any development software, to use this type of mechanism in which it explains at the same time visualize your findings. Now the purpose of this unit is to show you how you can do some data science analysis in a visualization matter. Is not programming per se, more it is how you can visualize your data and how you can run some modules in within this data to better understand what's going on within the data that you are analyzing. So first of all, when you open, after you download R and R Studio, all you have to do is to open the first file called intro packages, in which I listed a couple of packages that we're gonna add to the default environment that comes from R. Now, how you start, even not like your first script with our Markdown language, is just try to go from the file and create a new file by using the R Markdown option. So this is one of the options when you create a new file. And you name your file, and automatically it gives you the options what kind of document you are creating. We're gonna leave it as a document optional, but here you have the option to generate HTML file or PDF or a Word document, and it's up to you how you like to save your document and revisit them in future. If you prefer the HTML format in which you might post it on the internet, that will be the way to go. If you prefer to save them as PDF files, you pick the second and the third. So let me open just this new file, intro, to show you what R gives you as an option. I'm gonna click on this to clean up my space. So from the R Studio video introduction, you learned about the environment of R Studio. So this is the area that you write your code. This is the area that whenever you write your code, whatever generated as a result of this code is gonna be posted in this window, the console window. On the right side, the environment in which you can see what kind of variables you have generated or data you have added to your environment and the values of those objects that you created. And in the lower area, you have a couple of options. So in the time being, I'm looking at the files. Those are the files that I'm gonna use, which is directed in the location that you put your repository in R. So also as part of the environment, when you installed R, you can go also from the preferences, which is under the file option, and look actually where is actually under the R Studio icon. You can see where the R Studio, so look at the preferences, where the R Studio is putting the code when you are running your environment. As you can see, there is a specific location. The R workspace in PC or Windows will be exactly similar. Now maybe when you open your R Studio, you don't see it dark like this, but I prefer to make it dark because I'm recording, so I make sure the text, you can see it within the Zoom session. But the appearance, the default appearance will be will be something like maybe classic or modern, one of those, and will be not dark as you can see it in my end, will be white. So but you can change that environment the way you want it. Okay. And here is the part that is the setting for R Markdown. So if you see something different than the one I am showing you your environment is because I selected some of those. Now I will tell you what you have to select to see the result in the same way I'm gonna present in this session. So first of all, from this cylinder icon, you can select how the output of the results gonna show up. So I prefer that to have the output as shown over here. So the default will be in line, and so maybe the default in your end will be preview in Windows, so make sure you have it preview in the viewer panel. And let me see what kind of changes I made over here. So you can have similar to me so you don't get confused. So make sure you have the following selection: preview in the viewer pane, which means like whenever I'm running this code, it's gonna be here and not underneath it. You might see it at the beginning without changing the setting. The result automatically gonna be inside the R Markdown file. What else? Preview the images and equations. The chunk output in the console. Also, maybe you will have it select something different. So make sure the result's gonna be in the console. So let us go back to the first file you opened as a Markdown file in R, and that's automatic code being generated for you just as a test to show you how it works. And when you open the first file, this is like your beginning file. You can see here, just to give you the name of the file, you might decide to have it differently. So I call it intro. So when I'm saving it, I'm going to be saved like intro. The author is automatically taking the name of the person who installed the application, when I created this video, and the format. If you recall, I picked HTML document. That the format is going to be associated with the output when I run this file. Now there are some auto features. So here the echo of the results. So I'm going to talk afterward about this. So the same matter how you want the result to show up. Do you want to show it step by step, or you want to show it at the end? So you can control all the environment. So we're going to leave the setting as it is in the time being. What it did here, there is a data set called cars that already built in R, and it's trying to test the R Markdown file with this data to see if it's working or not. So pay attention to the following. Anything in this area where it starts with bracket R and end with those 3 dots, okay, before 3 dots, then mark it R, this is like a chunk of code. Then whatever it doesn't include that, it's like a text you write, and you can write whatever you want, and R will ignore it, will not execute it. Okay. So this is where you put your summary, your guideline, whatever you want to explain what is going to happen in the next chunk. So next to each one of those, to the right, you can see this green play button. This is where you run this chunk of information. Since this will not do really affect anything in the time being, is gonna just setting up the environment, so you can run it and be you will not see result. But let us see the result of bringing a data set called cars, and the summary is going to give you the statistical summary of this data, showing you some information about this data. So let me run it. Here we go. So all is telling us that we have this data, and this data consists of 2 attributes: the speed and the distance, and in each one we have some information associated with it. Let us do something else. Let me bring the whole data set and put it in an object, and then let me see the summary. In this way we can really investigate further what cars is. So imagine C is an object that I'm gonna put the data in, and I'm gonna use the operator that is get. The operator gets what it does. Actually, it brings whatever you write on the right side, assign it to the whatever you write on the left side. And you can use equal in R, which is really equivalent to this operation, but because equal is used in many different other type than assignment, so sometimes you might get confused which one is which. So I prefer to use the arrow dash symbol for getting the result of whatever you write to the right side of your line code to the left side. In this case, I'm gonna just add the cars and just run it. So in this, you can also run portion of the code by selecting that code and clicking on Option Enter. This is on Mac, where in PC you're gonna select Alt Enter after selecting the code. So now if you look at the right side, we should see this object that I called C. It's available under the data, okay, and here is the data. If you click on it, you should be able to see those elements. It's telling you that we have about 50 entries, 50 cars, and each one of them that has 2 attributes. So total columns is 2, one of them is speed and the other one is destination. Again, this is just for testing to know if your R is working correctly and you are seeing the results. Now let me also say the following, that because we selected the setting to show the result, let's put it on the chunk output. Yes, keep output for the time being. So now whatever we are executing is going to be down. Some other people prefer to have it directly after the code. It's up to you. So let me run now the summary again, and you can see the result down. So all it did here, it tested and brought me some, information about the statistical information about this data. So the mean, the minimum, the maximum, the mean, median, and the first quartile and the third quartile. So some basic information about those 2 columns of variables. Now let us start how we're gonna work with this. Okay, so let me run this. This is nice also to see it, the plot. So if I want to run a plot about this specific data, it's gonna run some information. Also the pressure is another data is available in R, is giving you the information over there. Okay, so now we know that whatever we're doing here, the results are in the console and in the plot at the same time. That's just for testing our program. Now, so let us start with the data that on hand, and how we're going to build the data visualization aspect. So this is the way I would advise you to rename this document that we started with your maybe summary, with your name, so you can, whatever you learn from the Zoom sessions, you add them to this file, and you try to build your own library from now on, just to practice. Also, by the way, since I'm sharing those documents, you can practice within the document that I am sharing. It's another way. Sometimes students, I notice, they get conflicted about what they wrote or what the document I give them. So it's handy to have your own file and to build your library from now on. Okay. So first of all, let us start with the intro package. So this is another file I created, a markdown file in R, in which I added the packages that I'm gonna use in this course. And the way we're gonna go with this course, as long as we go further, we can add more packages, but in the time being, those are the one that the starting point that I will need from you to install. And when you run this this code, this chunk of information is gonna use and add packages to your library, okay, beside the default packages. I'm not going to run it again because I already run it and I have the information listed in my package. But from your end, you will need to run those to be able to use some of the functions that we're going to use in those upcoming lectures. Okay, so let us start just to understand, and we're going to build now on the data visualization based on the information we have from those packages. One of them we're going to start first, which is the Gapminder package. That it is a data analysis package that provides you with some data, and we can really utilize it to build some plots and start understanding how we can visualize data, understand what is inside this data. Okay. So after you run this and make sure everything is running, and how you can make sure everything is running correctly, you're gonna get some reflection of errors if it didn't work, and also you can compare if those libraries, if you can search for them inside under the package tab on the right side. You can search to see if those are available for you in your own application. After getting and installing those packages, now you are ready set to start your getting started. Very simple introduction in this video, in this session, to how you can to build your knowledge with the data visualization using R, and with a specific type of R, which is the Markdown files. Okay, so first of all, I am gonna use the Gapminder. Note that whenever you install packages inside R, you have them in your library, but when you want to use them, you have to call those libraries. So those packages, even if you have them in your library, but whenever you're gonna use them, you have to tell R that's gonna put it in the buffer memory, so it knows what's gonna use. It's not wise to put all of them in the library and you're not using them. So you're using a big chunk of your computer memory, and where you are not, using it really per se. Okay, so let us call the library Gapminder, and you can do so. So let me show you just how you start even with a new file. You can from here click on insert, and you can click on the R. So as you can see, R provides you a chunk of block where you can add your data. So imagine that in that chunk that you are bringing the one of those libraries, the Gapminder. So from your end, what I want you from now to do is, yes, bring an R code and start practicing parallel while I am explaining these concepts. And you're gonna have a copy of the video in what we did in this session, and I will look at the chat and the questions you have in the chat and try to answer them parallel, and after the session send you the answers. But in the time being, what I want you to focus on is to try to practice as much as you could parallel with me, because it's the only way you can see the issues that might raise while you are practicing. So in the time being, while you added this R code, I would like for you to type the first chunk from here, which is the library, calling the library, and library is a function which is a built-in function in R, and between parentheses we're gonna call a library named Gapminder. Okay, so the moment you called it, now inside your chunk, run it by selecting it alone and click on Option Enter or Alt Enter in Windows. So what's happening now, as you can see the console respond, the library was called, and now it's part of the buffered memory to use it. So assume that we want now to save that so I can see it, to see what's going on inside this library. So let us which consists of data, let us call the gap equal Gapminder, or in our better way of using the gets command. So let me get the data gapminder and put it in an object gap and see what's happening here. So just click option enter, and now we have it inside our data. So if we want to look at the gap, you can double click on it. So you can see now we have the following data. The following data consists about 1704 entries, which is country names, and as you can see, some of them are repeated, and because each entry represents specific years. So we have a country column, the continent belongs this country to, and this data ranges between 1952 to 2007. So this is the length of the data we have. And then the life expectation in this country, the population of this country, and then we have the GDP per capita, the last column. So those are our data. We have 6 columns, 6 attributes, and this is the data we're gonna start our analysis in. So let us go back to our file, and now the next step, also I would like to call another library that we will use a plotting ggplot as part of it. And this library consists of many different functions. This is not a data library. This is a function library that help you in plotting. So let us the same, select it, and with option enter. Now we call the library, and since we didn't get any error, so we are fine. The next step, this is we're gonna build our first visualization. So we are gonna tell R, we're gonna use data. So this is the ggplot, a plotting function which is more advanced than the default plot that comes with R. So ggplot is gonna take an input, the data. So I use the gapminder, but you can also use the gap since you have it in your library. When I wrote this code, I didn't use the object gap, but to show you how it looks, I stated it. So you can use any one of those, will work fine. So what I'm saying here, please use the data gap, save it in, consider it as the data input for this function gapplot. Use a mapping function that comes in this data, and this mapping function is gonna use the following as an x-axis, and the following as your y-axis. So that's how it's gonna be plotting. So the GDP per capita will be your the x-axis, and the life expectation will be your y-axis. Okay. So far is very simple. All we ask is, this is the data that we're gonna use, and these are the x's and y's. And the mapping function, this is an essential function. You're telling RStudio, we're gonna map the following axis into this plot. Okay, and the function AAS, it's just the you are calling it's what you use in order to provide the mapping to your plot. So if you run this and it's on, okay, you can see nothing happen, and if I click on the plot, you will see nothing generated over there. Now if I call the P, that object I created that I put the plot in, now you should see the plot being generated on the right side. But unfortunately there is no data in it, because we only give information about what is gonna be mapped as an x-axis, which is just GDP per capita, and what's gonna be mapped as a y-axis, which is the life expectations. Okay, but we didn't plot anything inside this. We didn't give the what kind of method to plot. To be able to do that, you are going to add something additional to the upper, to this equation. So what you're gonna do, you're gonna say Okay, now I'm telling you, and this is what I want you to follow from now on, that this is the easiest way. You start first by creating your mapping procedure, what you're gonna plot, and then you keep adding on top of it as layer on top of layer on top of layer, so you have a better understanding what's going on inside your plot. Okay, so if I run now the following command with Option Enter, you can see now we have the data point plotted. So we added, in addition to the mapping, those are the X and Y, we called a function geom point, and geom point is the one responsible of getting the X's and the Y's and plotting them on top of this first mapping layer. So now you have every point in this graph represent a country in that specific region. So every and year as well with the life expectations. Okay. So this is like a country by GDP per capita and the life expectation, each one of them in that data. Okay, now what we're gonna add on top of that is we are gonna add another thing, which is now we're gonna add what is called the smooth. So if you want to see how the distribution of this data is really happening in this graph, so on top of this, you say I'm gonna add a new function, which is the geom smooth. Now pay attention, if you write this from the beginning of the line, you will get an error in R. So a lot of students make this mistake. This is a continuous, and for some reason R, well, if you cut the line and start a new line, will consider new function and will not know what to do with it. Okay, so now all I'm saying here, you started with the first layer, which is the X and Y, then you plotted this, a scatter plot by using geom point function that is part of ggplot, and now I'm gonna add some smooth to see how the distribution of this scatter plot is in this data. So if you can run the whole, or you can run just that part. Option Enter. Okay, let me run it, all of it. You should accept it. So as you can see now, what it did, it created a distribution of this data we're using the smooth function to show you the projection of your data in those two variables, in the life expectations and your GPD per capita. Now pay attention, if you switch those two functions, you start first by just asking about your okay, if I first started by saying that I want first to add the smooth and then the point, you will get a totally different picture. So let's try it. So as you can see now, what we had before, we put first the scatter plot and then we run the smooth on top of it. Now if you put the smooth first and then the point, you can see the point are on top of the smoothing function. So, and it's up to you what you want to represent, and typically what you do it in the opposite way, of course. You first write your point, and then you add your smooth function. So let me bring the smooth function one more time. Okay, so this is how it's supposed to be. So just pay attention, and again, the idea here is not to teach you how to draw, more how to use this function that helps you in understanding the data. So And the idea of this first session is just to get you set up with the environment of the available for you in R. Now, the next function, what usually you do beside that is the following. So I'm gonna just take off those examples. What you usually do, so you look at the data in this case, and as you can see, usually it's like when you have a currency data and you always have this skewed data because a lot of people are concentrated a lot around the medium of the currency salaries, maybe where how much they make. And then you have those outliers, the multimillionaires who their salaries is high and it's like an outlier, so it's gonna screw all your data. And typically a problem like this, what you do, you use a logarithmic scale to help you see the projection of your data in a better way. And this is what I did in the next step. So let me use the following function, and we are adding, as I said, you start with your data, you plotted the point, you created the smooth, and you saw the projection of your data. Now on top of that, I'm gonna add a scale. Okay, I'm gonna add the scale, the logarithmic scale, in a very simple matter. So all I'm saying that this P, that's an object that I'm holding my plot in. First, I put the axis and the x and the y axis in it. Then I put the points on the plot, another layer. I smoothed it. Now I'm telling it to change the scale of my x-axis to logarithmic scale. So let us run this part. So now you can see the data in a better projection, and you can tell how the description is. So you are having it is raised to the power of 0.3, 0.4, 0.5, a logarithmic scale, and you are looking and observing how the distribution of this data is going on. Now, next, what we're gonna do, it make logic now to do some more fixing to your visualizing plot. For example, the GDP per capita, this is represented by dollar value. So it's good to mention that on your x-axis to make it, on it. Also, you might decide like those y-axis and x-axis really are not written in a good way that typically you would like a plot to have the labels corrected in this way. Also, you would like to have a title, maybe subtitle, maybe also add a caption underneath this plot to show that from where you got this data that you're plotting belongs to which data set that you are using. Okay, so in order to do that, so we are done with this part. I'm gonna do the following. So instead of just using the default, the scale of the x-axis as a logarithmic scale, I am telling it, beside that, use the labels and make sure the scales is presented by dollar, and you have this colon sign. This is a part of our language that shows you in this function I'm gonna use a specific measurement, which is the dollar. So let us run this part. So now you can see the changes underneath. So now we have on this logarithmic scale represented by the dollar sign, 1,000, 10,000, 100,000, which makes a much better representation of your data. Okay, now we are getting a little bit an effective way of looking at the data. Now, of course, you might decide to change the smoothing function and to call a specific method like the linear method to plot your data. Now, sometimes might be correct, sometimes may be wrong. Maybe the distribution of this data is really not a linear a linear function. So let us try to run this. Done. Sorry for that. Okay. So this is another method that you can use, and I can, somehow I can see it's not really a linear. You can see that it's more like you have a polynomial function, maybe second degree polynomial function. So I'm gonna go back to the previous method, and there is something also called the gamma method that will show you the distribution as it is without enforcing any linear function on top of it. Or you can go back to the default setting of the smooth function. In the time being, what I'm trying to do here, I would like to emphasize one issue that some will think about, how about if I want to change now the color that of my plot. So here where you are enhancing the look of the visual look of your plot is not about the actual importance or the actual modeling, but it's more about how you can visually make it look better. And one of the mistakes that really known that being used, that if someone decided inside the mapping function to change some of the coloring aspects using the color equal maybe in this case purple. So let us see what's gonna happen here. And I'm gonna remove the following. Okay, so let us just run this part. So as you can see here, what you did, you changed the scatter plot of your point. So far here it's really not so problematic, but if you go further, so let me go by using the smooth after that, and let me use the typical smooth, that we learned in the previous step, just the default setting. And let me use this one. So as you can see, the purple that you picked is becoming part of the mapping algorithm. It's not only affecting your points, but also is affecting the smoothing. So as if you are adding a feature of this color to what the data represent itself, which is not the case. So yes, you can use the color if the color is part of your data inside the mapping method, but if it's not, I would not advise you to do it in this way, but rather, okay, let's go back to how it was, but rather to use it when you are actually doing the points, when you actually only you want to influence the point you are drawing over here and not the total function. So let us put it in this way, and sometimes R helps you, tells you that something is missing here. Like parentheses, you can see the red line underneath it. Now it's fixed, and also here is telling you, yeah, this is too much, you don't need that one. So let us see now the difference between those two, and I'm gonna remove that because something you will add in future. So instead of using the color inside the mapping procedure of your data, which is mapping the data points in your data set to your plot, but using it when you are mapping the actual point of those data. So let us use the following. So now you see the difference. So using the mapping of the point and what they represent, country, specific countries, life expectations, and the GDP per capita, this is the point that you change it to purple, and not whatever this data represent as purple, what we did previously. Okay, now beside that, you might make some additional changes. So some of those additional changes, you can change the alpha, which is how much the painting strength of your point. So if you want to make it less, just to see where the concentration is actually is, like you see some concentration here in this area. And also the size, if you want the size of the point to be changed. So that's the method you would use. So let me run this part. Okay, so you can see the difference now. So so this is like, it shows you where exactly most of the countries are falling into. Okay, now as we said before, you can start building on top of those. So this is our first layer. We mapped the X and Y. Second layer, we put the points on the plot, and we made it a little bit fancy. And then we created the smooth function to see the projection of our data, how it looks like. We changed the scale to look like to be a log scale, because this is a currency value, and most of the time with currency values you prefer to do a logistic values of it, because the data is skewed in general. Okay, so let us run this part. So now, so far we made a better representation. Now you want to fix the problems you have on the labels, the naming convention. So instead of using the life expectation that came from the data itself, it brought it from this value here, and the life expectancy from the attribute as it is, you want to make it a little bit, it looks better. And that can be done by using another addition. So we are adding a third layer on top of this plot, and that's all those are part of the ggplot functions, and there are plenty. We'll talk about them during the semester. So you can add this by using the labs function, in which you can give a specific name to your axis, specific name to your y-axis. So the x-axis, the y-axis, you can add specific title, you're going to add subtitle, and the caption that's going to appear lower here. So let us run all of it and see how it goes. Now, since we're going to run it all, you can decide to run it by using the chunk run. Okay, so now we really have a much better. So the effect of using the changing the label of the x-axis is the following. This is the GDP per capita. Okay, then the y-axis here, and the title, economic growth and life expectancy. Then the subtitle automatically gonna get lower values. So this, each data point are country, years, association in it. Now what else? And this here, the data source that you added to the Gapminder from where we took this data. So far I would say this is a good starting for us to play with the data. Now let me give you the whole story. Now we use something very similar you can do only by using the R script. So let's see the magic of using the Markdown R type of files. So if you pay attention to this neat icon on top of your code, click on it and see what's going to happen. I recall we did the HTML version of Markdown. So it's going to run the whole code that we created, and it's going to generate an HTML file that you can view over the internet if you saved it, or if you want it in a PDF file, so I can show you exactly what happened. So let me change the setting of this file, like to PDF or to Word document if you want. So I change it to PDF, and now I can run it, and it's gonna create a PDF file like I can save in my folder and reuse later. Okay, so those are the all steps that we used in this file. Okay, and let's see where it is. Window, run it again. It's down there. Just it's easier just to rerun it again. So now you have this PDF file that you can save it. So I'm gonna save it in a specific space. It's now gonna be in the same repository, so you can click on your file, save as, and save it in the location that you want it to be available for you. Okay, so it's the view is gonna available within your data. So if I open, let's see where the file is. Okay, so I'm putting everything in this folder. It's gonna be part of the folder, so you cannot save it directly, but that's the way. So it's gonna be available for you from where you started all your PDF file, where you put your markdown file in your computer. So now we have it. This is complete function that we use, and as you can see, when you see the first R markdown file, you start understanding that, oh yeah, I can now start writing here. I can start hiding some of the stuff that I don't really care about, and start writing what is all this about. This is the data visualization, getting started, which libraries I'm gonna use, and start explaining the geopoint function, so I can remember what I did in it. Then maybe the smooth function, and etc. So this is a very neat way that R is using. Now, what I would like from you to do in the time being is to repeat all what we did in this video, this session, and to not to be worried about making mistakes. Always you can solve those mistakes. So try to and you will not learn without typing. So I'm explaining the concepts here because I want you to understand how to visually understand the association between what you write and how you plot visually your data. But at the same time, you will not memorize those functions and the meaning of those functions unless you type them on your own. So try to practice with those. And again, this is not a course of teaching you how to do linear regression or modeling. The idea is you have some knowledge in those aspects, and here we are learning how to create those visually within R. Okay, so that's it for this session, guys, and we'll see you in the upcoming session. And please put your questions, if you have any questions, on the chat. So I will leave it open a little bit so you can ask some questions. I will answer some of those in the time being. But if you have, after you practice, you have some issues, post them on our Slack shared website, and that's it for the time being. See you next session.